Assalamualaikum warahmatullahi wabarakatuh. We are from group 2. We will present about experiment 5, which is bending moment. This is our team, myself Nurul Afifah, Muhammad Azhan and Umar Irfan. Introduction for this experiment. Bending moment is the reaction induced in a structural element when an external force or moment applied to the element to bend. The most common of simplest structural element subjected to bending moment is the beam. A beam which is simply supported at both ends. The ends can only react to the shear loads. This experiment measures a material bending moments when subjected to different distance same load and same distance different loads. From that, it can be measured the resulting bending moment with a suitable instrument. Objective for this experiment is to measure the bending moment of material when subjected to different loads at different distance. First scope is to study the relationship between constant weight of loads applied on P1, P2 and P3 from 5 Newton to 15 Newtons. The difference distance of P1, P2, P3 and B from A, which are 130 mm, 260 mm, 530 mm and 800 mm affect bending moment. Scope 2 to determining the difference weight of loads and the same distance of P1 and P3 from P2, which is 130 mm that affect the moment form. The range weight of loads used is between 0 Newton to 50 Newton on each hangers. The distance of P1 and B from point A are 130 mm and 420 mm. Scope 3 to discover the percentage error between the theoretical value and experimental value obtained.
Theory or working principle. Bending moment is defined as the reaction developed in a structural element when an external force or moment is applied to the element that causes the element to be bent. Bending moment at a section of beam is calculated as the algebraic sum of the moment for all the force acting on one side of the section. For example, consider the following figure which show the free body diagram of a simply support beam having P1, P2 and P3 as the applied load on the beam and RA and RB as the support reaction. Okay, in this experiment, we use the moment formula to calculate the bending moment for the beam. The formula is MB equal to FD, where F is force and D is the distance. We also find the percentage error for the experiment using the formula percentage error equal to modulus experimental minus with theoretical and divide with theoretical and multiply with 100 to get the percent of the percentage error.
This is the apparatus setup. We have a beam, came up with point A, point B and point C in the middle. P1, P2 and P3, beam support and load.
Okay, now I will present about methodology part 1. So first, the beam has been set up. Second, P1 to P2 at a distance of 130 millimeters, while P2 to P3 are 270 millimeters apart. Next, the beam has been adjusted using the spring balance until the liquid in the balance level. Record the initial data. Fourth, the 5 Newton load has been attached to the P1. The spring balance has been adjusted until the liquid in balance condition. Fifth, then take the load and applying to the P2 and P3. 6. And the final step repeated with a 10 Newton load and 15 Newton load. So now I will explain the methodology for part 2. First, the beam divided into 3 parts, P1, P2 and P3. The distance is the same, which is 130 millimeters. Next, the beam has been adjusted using the spring balance until the liquid in the balance level. Record the initial data. Third, the different load 2 Newton, 4 Newton and 6 Newton has been attached to P1, P2 and P3. The spring balance has been adjusted until the liquid in balance condition. Fourth, then take the data after the liquid in the balance condition. Fifth, step repeated with increasing the load to 4 Newton, 8 Newton and 10 Newton.
Okay, now we continue with the result. Okay, as you can see, this is the result that we get from the experiment. For the first is part 1, which is same weight of load and different distance. Okay, for the calculation part. Here we provide for you some example from the value that we get in the table. For the experimental value, we use the formula net force multiplied by the length of spring balance, and we get the experimental value equal to 450 Newton millimeter. For the theoretical value, first we set the moment at B equal to 0, and then RA multiply with 800, which is its distance, minus with P1, and its distance is 670 equal to 0. And then we get RA equal to 4.1875 Newton. And then to calculate the moment, which is the theoretical value, we use formula MC equal to RA, which is the RA that we get from the calculation before, which is distance 260 minus with P1 multiplied by 130, and then we get the moment at C equal to 438.75 Newton millimeter. Okay, this is the result that we get from the experiment in part 2. Okay, for the experimental value, we use the same formula as before, which is net force multiplied by the length of spring balance, and we get the experimental value equal to 1200 Newton millimeter. Okay, same like the slide before. First, we set the moment at A equal to 0. Then, RA multiply with 800 minus P1 multiply by 670 minus P2 multiply with 540 minus with P3 multiply by 410 equal to 0. And then we get the value of RA equal to 7.45 Newton. And then we calculate the moment at C. And then we get the moment at C equal to 1677 Newton millimeter. And now we continue with the discussion part. Okay, this is the graph for part 1. From the graph, we can conclude that when the load is higher, the experimental value and the theoretical value will be higher too. Okay, this is the graph that we plot from the experiment in part 2. Okay, any observation during the experiment conducted? Spring balance reading increased with the increase in the value of applied load. Experimental value of bending moment also increased with the increase in the value of applied load. The increase in bending moment value occurs due to the increase in load that causes the beam to physically bend downward. Second, comparison between the bending moment value obtained from the experimental and the theoretical calculation. Provide justification for any difference. Okay, From the table, we can conclude that our experiment is achieved because the percentage error that we get is below than 20%. Okay, this is the table for percentage error in part 2. Here I want to highlight for the load P1 equal to 2 Newton, P2 equal to 4 Newton, and P3 equal to 6 Newton. Here we get the percentage error higher than 20%, which is 59.75. Here maybe we do some error when taking the reading. So percentage error is higher we get in this experiment. Others we get below than 20% and we achieve the objective of the experiment. Conclusion. To sum up this experiment, the value of bending moment that obtained from this experiment was verified with the theoretical value that has been calculated. There is a slight difference between both values in which may due to the some errors occurred. That's, despite that, the experiment result in part 1 and part 2 show that the theory of bending moment is applicable in calculating the bending moment. Hence, the theory is proven true. The bending moment will be double if the load use double. Moment diagram can be easily drawn if the shearing force diagram is known. Therefore, the objective of the experiment are achieved. Possible error and improvement. First, I must be perpendicular to the scale to avoid parallel error. Second, make sure the air movement is suitable before doing experiment to confirm the hanger and load are in proper way.
So next, I will present about the safety procedures. First is the eye must be perpendicular to the reading of the spring and liquid to avoid parallax error. Second, do not place load beyond the capacity of the apparatus to avoid breakage and damage. Third, always ensure correct hanger spacing before placing load to obtain correct data. Fourth, wear a lab coat and closed shoes when doing any experiment. Fifth, hair in a neat condition for male and non-Muslim students to avoid injury. Okay, so this is all the references that we used to make this experiment.